Hello and welcome to the first episode of Petrus Tech. Today we are going to be taking this HP ProBook 440 G2 laptop and installing Arch Linux on it. This is, I want to say, a 5-6 year old laptop. It has a 5th generation i5 in it, one of the ultra low power processors. I'm not sure of the exact model, but I'm sure we'll see it here in a bit. Let me go ahead and get this hooked up. So the first thing you'll need to do is create an Arch USB stick. I'm not going to go into details on that. You should just be able to go to the website, download the most recent ISO image, and write it to a USB stick, either using DD on Linux or on Windows. You can use Etcher or Rufus or some other tool like that. There should be plenty of tutorials on how to do that already online, so I'm not really going to go into that. I'm just going to assume you already have a USB stick to start up off of. Also, I should mention that this tutorial is going to assume that you are installing Arch Linux exclusively on your machine and not dual booting, and it's also going to assume that you already have, or not that you already have, but that you have a blank hard drive, nothing else on it, and or that you're going to erase everything on it. All right, so let's get this turned on. First thing you're going to have to do is get into your bootloader, or rather get into your BIOS to get to the boot menu. You can usually do that by pressing either Escape, Delete, or some other key on your keyboard. It's usually an F key if it's not Escape or Delete, to get into the options menu here. In this case, for this laptop, I just had to press Delete. And now we can go into boot device options. And we're going to do external USB hard drive, which is what it calls the USB stick. And here we have the boot menu. We're just going to go ahead and press enter, and we're going to boot into Arch. This is also going to assume that you're using Ethernet for installation. I'm not going to mess with trying to set up a Wi-Fi connection. Alright, so we are booted here in Arch Linux. And first we're going to make sure we have an internet connection. Alright, so here we have an internet connection, so we're good. Let's ping Google. Alright, so we do have an internet connection. Not that we need it just yet, but just make sure that's already set up. First thing we're going to do is we're going to look at the hard drives on this computer. In this case, I have... for the hard drive, you can see it's SDA there, 465.8 gigs. So first thing we're going to do is we're going to partition the hard drive. Alright, so we're going to do parted dev SDA. We're going to create a new disk label, and in this case we're going to be making GPT because we're going to be booting with EFI. And then we're going to create some partitions. So how you partition your disk, it depends on how you want to set it up. I normally have a EFI system partition, a boot partition, and then the root partition. And the reason why I have a separate boot partition is mainly because I usually encrypt my drives, or I use BTRFS for the root file system. But in this case, we're going to have just the EFI system partition and the root partition, which will have boot in it because we're going to use ext4 in this case. If you are using something other than the ext4, say BTRFS or something more esoteric like a ZFS or something like that, you may want to consider using a separate boot partition, mainly because Grub doesn't necessarily support everything that you may want to use. Also, we're going to be using grub here. We're not going to be using system deboot or anything like that, mainly because grub is generally simple to install. And on top of that, I never really messed with system deboot. I don't like the idea that everything goes on the ESP partition or the EFI partition. I like to have a boot partition that is at the very least ext4, and just have the minimal amount of data on the EFI system partition. Alright, so the first partition we're going to create is the EFI system partition. So we're going to do make part, and we don't care about the partition name or the file system type. So we're just going to start at 1 megabyte for alignment purposes, and let's just make this 128 megabytes, which is relatively small. There's not going to be anything on it. There's going to be like less than a megabyte of data on here anyway, so you don't need to make it this big, but I know some systems have a minimum size for the EFI partition, so I think Windows creates 100 megabytes, so 128 megabytes should just be just fine. So we'll do 129 megabytes because we want 128 plus the 1 megabyte we're starting at. So hit enter. So now we have one partition, and then we want to make our root partition. So we're going to do make part again, and we're going to start where we ended with the EFI system partition. So we're going to do 129 megabytes, and then we're going to just do 100%. And then the last thing that we're going to do is we're going to do set one ESP on, and this is going to mark the first partition as the EFI system partition. And here we can do print. And you can see the first partition is, well, it's 134 megabytes because of the SI to, what do you call it? The SI to regular conversion. So you have flags boot ESP for the first one, and then the second partition is 500 gigabytes. So we're going to go ahead and quit here. And then we're going to go ahead and format each partition. So the first partition needs to be FAT32. So we're going to do make fs.vfat and then -f32 for specifying that we want FAT32 versus, say, FAT12 or FAT16. dev/sda1. Alright, so that makes the FAT partition, and then we're going to do make fs.ext4 dev sda2, and just hit enter. So this is going to format in sda2. Alright, so and again, if you don't want to use ext4, you can use some other file system, but for these purposes we are using ext4, just one, because it's a common file system, and two, we should have the least amount of issues using it. Alright, so now we're going to mount these file systems. One thing we want to do is we'll go ahead and turn off A-time. What this does is by default, every time you access a file on the file system, Linux will go and update the access time on the file, and this causes a lot of unnecessary disk writes. So we're just going to turn that option off. That way, whenever you access a file, we're not constantly writing to the disk. So we'll do dev sda2, and we'll want to mount this to /mnt, which is just a generic place to mount stuff. And this is generally where the Arch tutorials will also have you mount everything. Alright, so then we're going to make a couple directories here. We're going to make the mount boot EFI directory, which is where the EFI system partition is going to be mounted to. And then we're going to also make a directory for the temp directory. Alright, and we're going to go ahead and then mount, same no A-time option, dev sda1 to mount boot EFI for the EFI system partition. And then we're going to mount temp. And this is mainly so the temp, anything written in temp during the install process goes into RAM instead of on the disk. since when you boot into a default Arch install, it's going to use a RAM disk anyway. So yeah, so we're going to do mount, then we're going to do T for type, and we're going to do temp fs, and then temp fs again, and then mount temp. All right, so we should be good to start the installation now. We're going to do pack strap, and then /mount, since that's where we set up our, basically the new root that we're going to be using. And there's a few things you're going to want here. So you're going to want base, which is the setup base packages. The setup base packages no longer include any kind of editor or Linux or anything like that. So you're going to want several packages here. So we want Linux, and generally you're going to want Linux firmware, since you're probably going to have some device that needs some proprietary firmware blob or something on it. So we're just going to go ahead and install that. We're going to go on Grub for the bootloader. We're also going to want Nano, or the editor of your choice. You can install Vi or something like that. But I'm going to use Nano, since it's relatively easy to use. We're also going to want generally sudo, and then bash, and then bash completion. And I think that's it for now. We can install a couple other things later, but this will at least get us set up here initially. So we'll go ahead and hit enter. And we're just going to let Arch do its thing to install everything. And again, this is assuming that you are connected via Ethernet. Ethernet is plugged in on this laptop, so we don't have to set up any Wi-Fi or any other kind of connection. We're just connected via Ethernet. All right, so now we're going to get into the configuration aspect of it. As you can see, everything installed successfully, so we should have a base system installed. It won't boot yet, but we'll be fixing that here as part of this. So first thing we want to do is we want to generate the fstab file. So we're going to type in gen fstab, and then we're going to do -u. That way uses UUIDs instead of device paths. Generally, I found device paths are somewhat stable. However, using UUIDs is a better choice. The device paths could change, let's say, if you boot with, say, a USB stick or something plugged into your system, and again, it gets initializes before your regular disks. In that instance, something might change, but again, in my experience, it typically doesn't affect very much. But we're going to use UUIDs anyway. So we're going to write this to mount etc fstab. Oh, we also need to specify mount. There we go, gen fstab -u, and then -mount or /mount, and write that to fstab. There we go. So we're going to go ahead and edit mount etc fstab. And take a look at it. Generally, I clean this up, but you don't have to change anything in here. This is just what it looks like. So we have our root partition here, ext4, and we have the no A time option that we specified. And then this is the EFI system partition, type VFAT, and it's also no A time. So let's just exit out of there. So we can change a couple other things while we're out here before we see what you're doing here. So let's do nano. We can edit the bootloader, or not the bootloader, the make init CPIO file, which is what generates the init ramfs. So let's go edit that. Mount etc make init cpio.conf. So one thing we'll want to add here, and this depends on your GPU. We're going to go ahead and preload the driver for Intel GPU, so that's the i915 driver. You can look in the documentation of Arch for other for other video cards. For instance, AMD's is AMD GPU. If you're going to be using the proprietary NVIDIA driver, I don't know what that is, but it's in the documentation, or you can use the Novu drivers. But this is mainly to get the early KMS. So here we want to just move, I like to move keyboard here in between base and UDEV. This is doesn't really matter very much for laptops, but in the instance of, let's say, a desktop, if you shut your computer off and then you have a new keyboard that uses a different driver that you plug in and try to start up, if keyboard is after auto detect, it's only going to have the drivers of whatever you have plugged in when you generate the init RAMFS. Otherwise, if you have it before auto detect, it's just going to include all the drivers, and then that way you're 100% certain you will always have keyboard access. I guess this doesn't matter much for what we're doing here, since we're not generally needing keyboard input before we boot. But if you encrypted your drive or something like that, you would need keyboard access before we fully booted, and therefore you'd want to make sure you do this. So we're going to go ahead and exit out of here. And then we also want to, let's see, we can edit. Let's go ahead and chroot in here. So we're going to do arch chroot and then /mount. And then hit enter, and now we're in our, we are chrooted into the system that we're setting up. So here we want to go do a couple things. So let's go edit the host name, or actually we just edited the make init CPIO file. So let's go ahead and update that. So we'll do mk init CPIO -P, and then I'll regenerate it with the new settings that we've entered in the file. All right, so let's go edit the host name. So we'll do nano etc host name. And then I'll just name this computer demo. And then we'll save that. We'll want to set the locale. So nano etc locale.gen. And here you'll want to search for your standard language format. So in this case, I want US English, so I'm going to search for en_US. And I want the one that's down here in the list. So here I have a couple options. So I have UTF-8, and I also have ISO 8859-1. Generally, you want the UTF-8 one, so that's the one we're going to uncomment. So make note of this en_us.utf-8. We're going to have to manually type that in here in a minute. So we're going to go ahead and save this. And if you didn't notice, I just uncommented that line. So let's go here to locale.conf. And here we're going to type in lang equals en_us.utf-8. And this is the same as what was on that line before, everything before the first space. So I'm ready to go ahead and save this. And then we're going to do locale-gen, which will take those settings and generate the locales that we want. So now we can also set up sudo. So what I like to do is copy the etc sudoers file to etc sudoers.d, and then we'll call it wheel because we're going to allow anyone in the wheel group to access sudo. And then we're going to go ahead and edit that file. sudoers.d wheel. All right, and we are going to do, so I'm doing Control K to remove a whole bunch of lines. And I'm just holding that down and until I get down here at the bottom where it says, uncomment to allow members of the wheel group to execute any command. We're going to go ahead and uncomment that line. And then we're going to remove everything else in the file. So the only thing in this file is allowing wheel or anyone in the group wheel to use sudo. So we're going to save this. And then we're going to go, let's go ahead and add a user. So we're going to user add -m, and then let's just call this user demo. All right, so this is going to create a new user with the username demo. And then we're going to add that user to group wheel. So we're going to usermon -a for append, and then -G for the group name, and then we're going to do say wheels, and then the username demo. So this is saying add demo to group wheel. All right. We can also go ahead and set the time zone. So we're going to do ln-s user share time zones. Or no, it's zone info. There we go. America. And then I'm in Phoenix. So I'm going to do Phoenix. If you're saying New York, you'll do a new underscore York or Los Angeles, or whatever your typical time zone is. There's also zone info US. And then you can use, if you use US, you can do Central, Mountain, Pacific, those general names instead of the location. But I like to use Phoenix, so I'm going to do America/Phoenix, and then we're going to do /etc/local time. So that's going to set the time zone for this system to America/Phoenix. So now we'll want to enable a couple of things. Actually, we'll want to install some more packages from here. So we didn't set up any way to get a network connection. We could use systemd networkd. I'm going to use the little bit easier option. I'm just going to go ahead and use network manager. So we can do pacman/x network manager. And then we'll hit yes. All right, so we've got network manager installed. And if you want to use Bluetooth, we can also install the Bluetooth utilities. So we'll do pacman/s blues and then blues utils. And we'll go ahead and hit yes for that. All right, so now we'll want to enable some services. So let's do systemctl enable network manager.service. To enable network manager, we'll also want to enable systemd time sync d.service. So this will enable time synchronization. What else do we want to enable? There's lots of stuff I normally enable, but in this case we're not installing everything that normally install. So I think that might be it actually. So, okay, let's go set up grub. So grub should be easy. We just need to run a couple commands here. So we need to do grub install. And then I just like to install, do -- removable. And the reason is this will install everything into the /efa/boot directory for your system, which most systems will generally boot up on their own. It won't add a EFI boot entry or anything like that, and I found this just to work in most cases without having to fuss with EFI boot manager or anything like that. So we'll just go ahead and install removable. And then we need to make the grub configuration. So grub make config -o boot grub.cfg. All right. Oh, and this reminds me one other thing you want. This is an Intel system. We want to go ahead and install the microcode updates. So we'll go ahead and do pacman/s intel-ucode. And then we'll go ahead and run the make config command again because that's going to detect the microcode updates and include that in the bootloader. I think that's it. I think we should be able to boot now. So we've created a user. We need to set a password. So we need to set password for the demo user. So we'll type in password and then demo. And then we'll give that user a password. You could also set a password for root. But in a lot of cases, most systems now recommend that you don't set a password for root. That way you at the very least need to authenticated as something else before you were able to authenticate as root. So we're not going to set a root password on this. All right, so we should be able to exit out of the system. We'll go ahead and look what we have mounted here. So we're going to unmount everything under mount, so umount-r/mnt. All right, and we should be able to reboot now. So I'm just going to type in reboot, and I'm going to remove the USB stick, and hopefully we boot into our new Arch system. All right, so here we get the boot menu. We're just going to let it time out and start Arch. And here we go. We got our login screen. So we're just going to log in. All right. And I'm just going to go ahead and change to root. All right, so that means we've set up sudo correctly. Let's see. We have an IP address, so network manager is working correctly. You can also type in nmcli to get more information about that. All right, so now we have a working Arch system. Now what we want to do is we want to install a desktop environment, get some hardware acceleration working, and then let's see if we can get online and use something like YouTube. So here now we're going to be installing a lot of stuff. So I like GNOME, so I'm going to go ahead and use GNOME for this example. So we're going to do pacman-s, and we're just going to type in GNOME. And there's a few other things. So I've noticed that some things don't look right if we don't have Deja Vu installed. So we're going to do gtf-deja vu. And then we're also going to install a generic font called Noto. So if we type in Noto fonts, here we have a few different packages. So we have Noto fonts, CJK for I believe that's Chinese, Japanese, those kinds of languages. Noto fonts, emoji for emoji, and then Noto fonts extra for some other languages. I think it contains Egyptian and some other hieroglyphic type languages in there. So we've got GNOME, we've got all those fonts. What else do we want? So that's the base GNOME. We probably want a browser like Chromium. And yeah, so this will get us the so we also want Xorg. So we're going to type in Xorg and Xorg-apps, which are groups for various Xorg things. And then we also want Xorg server. All right, so let's go ahead and install this. So in here, we're just going to accept everything for the GNOME group. For the Xorg group, notably, we do not want XF86 Video Visa. We would just want Xorg to use mode settings. So we're going to exclude number 1. So we're just going to do 2 through 48 to exclude number 1. And here we can install all these. And then we're going to hit yes, and we're just going to let everything download. All right, so all that's installed. We should be able to enable GDM and then reboot into the graphical environment now. So let's do systemctl enable gdm.service and enter, and then we're going to go ahead and reboot. All right, so we can go ahead and log in as the demo user. Super short password there. I'm sure you can guess what it is, but this is only a demo installation. I'm not actually going to be using it. So, all right. So here we've got the GNOME desktop, and we're going to go ahead and open up a terminal. And let's go ahead and make this. Let's go ahead and make this dark mode. Sorry, I'm overshooting here a bit because I'm looking at the recording of this, and I guess it's delayed a little bit more than normal. So here we're going to change the theme variant to dark. And then we're going to get rid of this window. All right. So we're going to go and change to root again, just because you're going to be installing some things. So now that we have the desktop environment set up, we'll want to install a few different things to enable hardware acceleration, both video hardware acceleration and like 3D hardware acceleration. So we're going to do pacman-s. Well, I guess 3D hardware acceleration should already work, since we're using the mode setting driver by default, since we didn't install Visa. So it's mainly just enabling the hardware video acceleration and then making sure the GPU 3D acceleration is working. So this is an Intel system, so if you have something else, you can go look up what packages to install in the wiki. But otherwise for here, since this is a Broadwell or newer system, we can use the Intel Media driver codec instead of the old package. The old package, I think, is what do you call it? What is the old package? I don't remember what the old package is. But anyway, there's, if you have something older than an Intel Broadwell processor, you'll have to use the old package. I don't remember what it is. You'll have to install that from. You'll have to look up the wiki to figure out what it is. But this is newer than that, so we're going to use Intel Media driver. And then we're going to also install the libva utils package. That way we can look and see what codecs we can use and whether this is installed properly. And then we're also going to want libvdpau vagl. So this is basically a wrapper for libvdpau to pass everything through to the VA driver, which is what Intel Media driver is. And then vdpau info. And then we're also going to want Mesa demos to check the 3D acceleration. vdpau. There we go. vdpau info and Mesa demos. All right, and we'll just hit yes. All right, so the wiki recommends you don't set environment variables for this, but I know for a fact, at the very least on this system, if I don't set environment variables, it's not going to detect what to use properly. So I'm going to go ahead and add something to the profile. That way, everything will always use the correct acceleration. So we're going to do nano. Let's do etc profile.d, and then we'll call this hardware excel.sh, and then we'll do bin sh just for a regular shebang line. Even though it's going to be sourcing it, you don't really need that. So first we're going to do libva, so we're going to do export libva driver name, and for the Intel Media driver it's going to be ihd. For other drivers, it'll be some other name. Again, the wiki will tell you what to put here. So, and then we also want the vdpau driver. This one is just vdpau driver._name, and here we're going to do va_gl. And then we're just going to save this. And we should be able to exit out of here. And let me turn my webcam off for a second. So now we're going to log out, and we should be able to log back in and have it pick up those settings. There we go. We'll go ahead and log in. Alright, so now if we open up the terminal again, we should be able to type in VA info. Alright, and as you can see here, it picked up the Intel HD driver. And then as you can see, the list of codecs that driver is able to use for this version of the Intel graphics card that we have. And if we do vdpau info, and if we scroll up, you see it says it's using the OpenGL VA API backend for vdpau, so that's the correct one that we configured. And then you can see it has some decoders here, which isn't as much as the VA, but it's fine. So at least we know that it's working. And then to check the 3D acceleration, we can do v blank mode equals 0. So this turns off the VSync for GLX gears, and we're just going to do GLX gears. So this was part of that Mesa demos package. And here we can see, so we're doing 8,000 or so FPS. Again, this isn't really a demo, but you can tell if 3D acceleration is working. If it wasn't, this would be way lower than this. So 3D acceleration is working. So that's about it. As you can see, now we have a fully working GNOME system. So we've got wired connected. We've got Wi-Fi. If we wanted to do Wi-Fi, Bluetooth says it's off. Oh, we never enabled the Bluetooth service. We installed it, but we didn't enable it. So we're going to open up the terminal, and we're going to do sudo systemctl enable -- now bluetooth.service, and then type in our password. And then now we should see that Bluetooth is on here in the menu. No, it's not. Well, it should come on once you restart. Fully charged. Since this is a laptop, we've got a battery. And yeah, so everything that you should need is enabled. There's other things that you'll probably want to do. You'll probably want to install something like an Office suite. You'll probably want to install cups for printing. Various other things like that. You can find that on the wiki. I think once you've gotten this far and you've gotten the system set up with a desktop environment, everything else should be relatively easy. Oh yeah, the last thing we wanted to do, we want to try Chromium. So we can go to YouTube. And let's see, what am I not going to get in trouble for playing? Let's just click on here. It's not getting an audio, so that's fine. So yeah, we're playing YouTube videos. Alright, so we can close this. That's it. I hope this was helpful if you were looking to use Arch Linux. And maybe we'll look into how to do other stuff in the next episode. Alright, thanks everybody. See you next time.